forward. So today we'll be talking about neural networks representation, and let's get to the basics of neural networks and its functioning. So this is how you represent a neural network. Almost every neural network, every neural network has a hidden layer, input layer, and output layer. And this is the most simplest representation over here. And this is what a three-layered neural network would look like. And note that this is the input layer. This is the layer which gets the data, and we feed data to the neural network over here. And these are the hidden layers. Hidden layers are primarily responsible for carrying out all the functions which neural network does, and then after that we have our output layer. And this is what a dense neural network looks like. So note that the middle hidden layer, all these layers are not connected to each other. They are connected to the previous layers and the next subsequent layer. They are not connected to each other in any way. And as we go deeper, denser, and create more denser neural networks, it's become harder for us to visualize what each layer is doing. So let's get to the basics. So this over here is called a hidden layer. So this over here is the input layer, and it contains all the input features which it collects from the training data. So think of this input layer as a vector. You can think of it as a vector, and then which comes the hidden layer. So hidden layer grabs all the characteristics, or it's taking data, all the input features from the input layer. So there are 4 nodes. So it takes all the input features, then it gets multiplied by its weight. Then we add a bias term over here, and then we add non-linearity to the function, which is given by activation functions which we have talked about earlier. And then over here, this is the output layer, which is responsible for computing the probabilities or predictions or whatever we want from a neural network over here. So we'll be expressing it with notation y hat. And so think of it as a vector over here, and this, let's say a superscript 0, and a is analogous to activation function over here. And after we pass all the input features to the hidden layer, it's going to get multiplied. All the input features are going to multiply by its weight, and so each previous layer is going to pass on to its features onto the next layer, and then they're going to be multiplied by its weight. Then we add a bias term for regularizing, and then we introduce non-linearity to the function so that we can come up with more complex decision boundaries. So we'll be representing hidden layer with a superscript 1, right? And then we'll be representing each layer, each node of hidden layer with a superscript 1, and then subsequent value of subscript would be the rank or the number at which node is located. So the first node will be written by a superscript 1, since it's the first layer, and then this subscript over here would depict which node are we talking about, which neuron are we talking about. And so it's going to be a11, and subsequently we'll be representing all these second neuron with a superscript 1 subscript 2, and subsequently. And note that this input, this middle layer, can be thought of as a matrix or the vector over here. So, and this is a just simple representation over here. As we have more neurons, this vector is gonna go more long. So note that each neuron would be carrying out different tasks over here. When we randomize it using numpy or np.random.random, what we do is we initialize each neuron with a different set of values, so that if symmetry breaking does not happen, each neuron would not be computing the same thing. We want each neuron to compute and come up with different set of vectors, and then we pass on that vector to subsequent layers. So each neuron will be computing different values, vectors. So we randomize it in such a way that each neuron will be computing different vectors. And so let's come to the final topic of our today's discussion: how many number of layers are in a neural network. So in a neural network, we don't conventional ways that we don't consider the input layer while counting number of layers. So only the hidden layer and the output layer are considered while counting the number of layers in neural network. And this convention has been adopted all over deep learning research, whether you see in papers or other courses as well. And so there's one thing which we need to talk about is all this hidden layer. It's associated with set of parameters which we have talked about. So this W is going to be vector, which will be computed by this hidden layer over here, and this B is known as biased vector, so which we're going to talk about later. And so the dimensions of W and B are going to be 4 by 3. Why 4 by 3? Because there are 4 neurons in it, and 3 because there are 3 input features over here. And similarly, the dimensions of bias vector are 4 because there are 4 neurons in it. So I hope you get a better intuition of how to represent neural networks and what's happening at the core when we implement or create layers in neural networks. Please share it with your friends who are learning deep learning, and thank you for watching it. Talk to you next one. Thank you.